All right. Hi, Algebra 1 kids. It's Mrs. Frybush. I just wanted to give you some notes from the class that we had. The very first day, we started doing solving one-step equations, actually second day, because we went through all the symbols. We went through 18 plus negative 12. We just discussed how if a negative is in front of a number like this and not between two numbers, this is a negative. Okay, now over here, I do have negative 2. Again, not between two numbers. And then this is a minus. Now, even though a minus is the same as adding a negative, we still call it a minus because when you use a calculator, you can use a different button for this, okay? So we went through these and we said that this 18 is positive because there's no negative up front. If I have $18 and I owe 12, I said negative is like owing, positive is like having. So if I have $18, so this is in the plus, and I owe $12, this is in the minus, I ultimately have more than I owe, so it was positive 6. We could also use the number line here and go to 18. 18 positive is right there. And we are going to go in the negative direction. Even if you forget, 0 is in the middle. It's neutral. If I go up, that's positive numbers. And if I go down, it's negative numbers. So moving left goes negative, and moving right goes positive. So this 18 is positive. And I want to move in the negative direction, 12. So I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I end up with the answer of positive 6. Oops. We also talked about using the calculator and how to do those. I can make another video for that just to refresh your memory. But the biggest thing about this lesson, even though we're going through these and we were going over like different ways to think about it, is these things down here, these 3. Because this is leading us into how we solve. 14 minus 14. Again, it's between them. So if I go positive 14 and I go back 14, I'm going to end up at 0. These two things get rid of each other. All right, negative 25 minus a negative. Minus and a negative is a double negative. They cancel each other out and make a big old positive here. Double negative. So now I have going back 25, but up 25. They cancel each other out and leave me with 0. They are called inverse operations. To get rid of a positive 14, you would subtract 14. To get rid of a negative 25, you would add a positive 25. Now that's easy for adding and subtracting, but division, you have this 12 over this 12, and they will cancel out, but there's a few things you have to think about. First off, this is negative. When a bad thing happens to a good person, that is a bad thing, okay? Positive times a positive is positive. A positive times a negative is negative. A negative times a positive is also negative. But when you have an even number of negatives multiplied, they cancel out to bring you back to positive. So when it comes to multiplying and dividing, it's not about like the size of whoever is bigger. Like this guy here, he was bigger, so his sign won. It's not size, it's quantity of how many. So there's 2 situations where the negative wins, and there's 2 situations where the positive wins, okay? So here, just like these 25s cancel out, these 12s will cancel out, and the only thing left is a negative. Now with division and multiplication, you don't end up with 0 like adding and subtracting, you end up with 1. 12 goes into 12 one time. 12 goes into negative 12, negative 1 time. We'll come back to this, so if you're still like me, don't worry about it. I promise you we'll come back to these because we need those for this. So the big lesson we learned last week was solving one-step equations, which means you should only take one move, if you will, like a chessboard, to come up with your ultimate solution. So number 10, if I read this, says 2x equals 10. So So the first thing I notice is I have an equal sign. I'm going to put this dotted line to kind of say, hey, whatever you do to one side, you must do to the other. I have 2x. So there's 4 operations: adding, subtracting, I'm going to say division first, and then multiplication. And I even wrote it really light because he is the invisible operation, if you will. You can always see if it's adding. You can always see if it's subtraction. You can see if it's division. I don't want to be division on here because it'll look like a fraction, like up here. But the one that you can't really see is this little sneaky guy here, multiplication. So we have this 2 and this x. There is not an add sign or a subtract sign or a fraction. So he is the invisible one. This is multiplication. So I'm going to sneak the dot there just to show you. So what you're going to do is you're going to do the anti-multiply. And multiplying and division are frenemies. They get rid of each other. So since there's multiplying going on, I need to divide. And if I do it to one side, I have to keep the balance and do it to the other. By taking this 2 times and dividing it by 2, the 2's cancel out. See ya. So I end up with x equals 10 divided by 2, which I could do that in my calculator, I could do it in my head. How many groups of 2 fit into 10? You should ultimately get your answer to be 5. And you could take that number and plug it into the original variable right there. 2 times 5 is 10. Fantastic. All right, let's go to number 11. I have x minus 8 equals 7, dot, 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 down the equal sign. That equal sign tells me whatever I do to one side, I got to keep it balanced over here. So now here is my x, and I can see what the math is. Is it add, subtract, divide, or the invisible? Well, I see in between them there is this minus, and so it's minus. In order to get rid of minus then, I'm going to do his polar opposite, which is add, his inverse operation. I'm going to add that 8. And the reason I'm going to add 8 is because I want the x, the variable, to be alone. I want to know what he equals. So I'm going to just do this. Now I have a little math problem here. This x is going to drop. The 8's are going to cancel out because that was the whole purpose. So on the left side, I simply have an x, and it equals 7 plus 8, which I can go to my calculator and see it's 15. And 15 minus 8, it does equal 7. Let's move on to number 12. Number 12 says 11 plus m equals 1. And I'm going to dot this line down. Again, it helps me organize. Whatever I do to one side, I must do to the other. M is the variable here, and that's okay. I'm actually going to even put the plus sign there just to remind myself it is positive. And remember, my operations are plus, minus, divide, or the invisible operator, multiply. I see that plus sign here, winner, winner, chicken dinner. I know I'm going to do the inverse, which is subtract. Now, m is the variable, so I am going to subtract 11. So I'm going to minus 11, minus 11. The whole goal of this is to get this variable solved, to find out what is m. What is going to m have to be to make this a true mathematical statement? So now it's time to do math. So I put the big old line to tell me to do it. 11 take away 11. If I do that right, see ya, wouldn't want to be ya. They should cancel out. M should be alone. And then 1 take away 11. I can go to my calculator. I can think of the number line, whatever you would like to do. If I have $1 and I owe $11, I ultimately still owe $10. Let's do a couple more, and then we will be done for you to practice on your own. Number 13, I have t plus 14. Dot, 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 dot. Is it add, subtract, divide, or the invisible multiply? I see that big old plus sign, so I know it's this. So I know I'm going to do his opposite. So I'm going to box this t here because the variable controls the problem. That's what I'm trying to find. So I see the plus, So I'm going to minus. Oops, 14. Both sides. Keep it nice and level and even and balanced. The t is going to drop. The 14 and the 14 cancel each other out. See ya. Ms. Parrish, how come you did 1 sometimes? Just I did. I don't want you to be confused by that. Equals 25, take away or minus 14. 5 minus 4 is 1. 2 minus 1 is also 1. Ms. Freibush thought of the answer 4. T is 11. All right, let's do one more. At least one more. Ooh, okay. 5w equals negative 35. Again, this is a negative because it's not between two numbers. So x minus 1, that's a minus. Negative x would be like this, that there's not 2 in between them. So between, minus, in front of, plain old negative. Okay. Dot, 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 dot. Do you see what I see? Add, subtract, divide, or the invisible, multiply. I don't see an add. I see a negative, but that's not a minus. I don't see a fraction. So it's the invisible guy. So I'm going to have to divide. W is right here. 5 is what is being multiplied with it. So I'm going to divide. Divide. These will cancel out and I will get W equal to, ooh, I go in my calculator, or I think about this and I say, okay, positive would be positive, positive. They're not positive. Positive would be negative, negative. I don't have 2 negatives. The other 2 situations have 1 of each. So this is going to be negative 7. All right. Here are the last 4 answers for you to have to look over. If you need to go over these, please take them to see your teacher so that your teacher can go over how to get the final answers. So this was a short little lesson in how to solve one-step equations.